Alright, here's 5.1, bisectors, medians, and altitudes in triangles. I'm going to break this up into two videos, 5.1a and 5.1b. Theorem 5.1, if a point is on the perpendicular bisector of a segment, then it is, and this may be a new word for you, equidistant from the endpoints of the segment. And equidistant, that just means equal distance or the same distance. So if a point somewhere here on this perpendicular bisector, then it's always going to be the same distance from the endpoints of the line that it's bisecting. Okay, and the converse just says the same thing but kind of backwards. It says if a point is equidistant, so if we know that it's equidistant from the endpoints of a segment, then it must be on the perpendicular bisector. Okay, so take a look here. It looks like we have a segment that is bisected into two equal parts, and it's perpendicular to this line LN. So this line LN must be the perpendicular bisector. So that means we should be able to find the missing links. So this should be 7. And these two links, 3x and 5x minus 6, should equal each other. So let's just set those equal. 3x should equal 5x minus 6. Do a little algebra. And we get that x has to equal 3. If that's the case, we could plug it back in, and right away we see that 3x has to equal 9, and 5x minus 6 has to equal 9. Alright, so we got all the sides, we found all the missing links. Now they want me to find the perimeter. If you remember right, perimeter is just the distance all the way around. So 7 plus 9 is 16, plus another 9 is 25, plus another 7 is 32. And there we go. Alright, next theorem, 5.4, says if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. And when we say equidistant, we're talking about perpendicularly. You see this little right angle here. I could zoom in on this picture quite a bit, and we'll see, yeah, sure, Q is equidistant from this side and from this side, but it has to be at a right angle. Whenever we are measuring distance from a line, it has to be at a right angle. So yeah, Q is equidistant from these two sides, therefore it's on the angle bisector, or if it's on the angle bisector, it's going to be equidistant. And that leads way to the converse of the angle bisector theorem, which says if a point in the interior of an angle is equidistant, meaning it's the same distance from the sides of the angle, then the point is on the angle bisector. Okay, so we need to use that information. If we ever see a point that's the same distance from both sides of the angle, we know that point is on the angle bisector. So let's take a look at this next problem. What do you know here? Look, we have two angles that are congruent. That means that this ray AB must be the angle bisector. Therefore, DB must be equal to BC. So that's how we're going to find the value of x. We're going to set these two things equal. X plus 7 equals 3x plus 3. Subtract x, subtract 3, subtract 3. These cancel. 7 minus 3 is 4. 3x minus x is 2x. And x has to equal 2 when you divide both sides by 2. So we found x, but they also wanted us to find the value of dB. So we're just going to take this and plug it in to dB, which means instead of x plus 7, we have 2 plus 7. So dB equals 2 plus 7, or 9. And we've done what they've asked. Let's go to the next page. Okay, here we go. This is for you guys to practice. I will tell you there's some information here that you're going to need to fill into the drawing. It says that KLJ is congruent to MLJ, so you're going to want to mark this angle congruent with this angle, and that angle K and angle M are right angles, and angle M is a right angle. So this tells us that this line here, LJ, is the angle bisector. Therefore, it is equidistant from this side of the angle and from this side of the angle. So you guys are going to solve that on your own. Go ahead and do that now. Okay, you should have got that x equals 12. When you set those two sides equal, when you plug it back in, you should have got that kj and jm are both 17. Okay, let's do the last problem together. Okay, use the following figure for the next 4 examples, and then it tells you that all these angles here are right angles. So let's mark that. It says HJL is a right angle, HGL is a right angle, HFE is a right angle, which is right here. I could screw that over a little bit. And that HKE is a right angle. So that's this one right here. And they want to know, how is HL related to JHG? Let's think about that a little bit. Here's HL, and here's angle JHG, and we can see that L is the same distance from this side of the angle as it is from this side of the angle. Therefore, we could say that HL is the angle bisector to angle JHG. Alright, well, if that's true, we should be able to find some parts. I put the little measurements in a different spot this time, but that's okay, because I wanted you guys to see it. So if this is an angle bisector, we can mark a couple things. We can mark these two angles congruent. We can mark this side congruent with itself. Alright, so if those things are all true, we would have angle side, or we could have angle side, or angle side. Point is, this triangle must be congruent with this triangle, therefore this side must be congruent with this side. So you should be able to say 6y equals 4y plus 18, and simply solve for y here. You get 2y equals 18, or y equals 9. And you should be able to plug that back in to get JH and HG. You should try that on your own. I'll do it here with you. JH equals 6 times y, or 6 times 9, which is 54. Okay. Go ahead and do the summary on your own. What can you conclude about point E? Here's point E up here. Explain to me how you know this for sure. Okay. Go ahead and try that on your own. Adios.